Hey guys, today's problem is sequential digits. So let's read the problem first. An integer has sequential digits if and only if each digit in a number is one or more than the previous digit. So basically it means that we sequential digits are the one in which the values are like this: 1, 2, 3, 2, 3, 4, 5, in which each the digit that are in the next one is increment by 1. Okay, so all this is the main concept what is the sequential digits. Okay, so return a sorted list of all the integer in a range low and high, in which low is included and high is also included. This bracket denotes that. If it is small bracket, then it means that high is excluded, and if it is small bracket, then it means this low is excluded. Okay, inclusively that have the sequential digits. Okay, so suppose I have a low 100 and a high 100. So I have, so suppose, okay, sorry, okay, so suppose I have a low of 100 and high of 300. So I have to find all the digits that lie between these, okay, which are in sequential digits. Suppose I got 1, 2, 3, which is belongs to this range. Okay, then we have 2, 3, 4, 4, 5, and 3, 4, 5. The thing is, this don't belongs to this range. Okay, so I'm not going to take this. I'm going to just return this. Okay, this is the answer. Now suppose I have something like low equals to 100 and high equals to around 2000. Okay, so all this range could be 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7. Okay, 6, 7, 8, 7, 8, 9. And if I take 8, 9, then I cannot take the 10. It will be some different value, so I cannot take this. Okay, so this is all the range. I'm just going to erase this. Okay, now what else I can take? I can take 1, 2, 3, 4. Okay, 2, 3, 4, 5, and so on till I can. No. The thing is, I cannot take 2, 3, 4, 5. 2, 3, 4, 5 is not in the high range, so I'm not going to take this. So the answer would be these all and this. Okay, so what's the brute force I can think of? I know that this thing is I can just iterate over all these and just check the number. Is it the sequential or not sequential? If it is sequential, then I'm just going to add this in my rest value. Okay, this is the brute force, in which the time complexity will be the n, where n belongs to high minus low. Okay, but the thing is the n value is 10 over 9, and it will be give the time complexity. It will give TLE. If I go for even n in which I am checking each digit, and that could be of n length, so it is basically means n square. So it is not a great complexity. So what else I can think of? I can think of the result is only few numbers. Okay, and the range is very high. So why don't I just use this range? Okay, so I know that each starting value is from 1 to 7 or 8, 9, and each value is this. So what I can think of, I just see what is the length of this digit. Okay, so let me build up a logic for you. L equals to 100 and high equals to 2000. So the thing is, the length is 3 and this length is 4. So basically I need 3 fills and I need 4 fills. Okay, so I have to fill these value and I have to fill these value. So each value will be starting from 1 to 9, 1 to 9 and same. Okay, 1 to 9, and this value will be here, 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 will be here. Okay, so it will be here, it will be here, it will be here. So 1 to 9 basically, in which I am going to exclude 1 to 9, then I have to plus 1 for this. Okay, so what it basically means, if I go for any digit in this value, then I have to choose an increment of this. So if I choose 2, then I have to choose 3 forcefully. I have to choose 4 and forcefully. If I choose 4, then I forcefully take 5, in which 6, in which 7. Okay, this is the thing. So what if I just iterate over all these? I know that how many dashes are there, so I can go for an I where it will be starting from 3 to 4. Okay, how many dashes are needed? So suppose this is dash, and let me check 2 dash. Okay, just tell me how many dashes we have to fill. The second would be the range of the starting point. The starting point would be it could be go from 1 to 9. Okay, and okay, now I have to fill from the starting point. Suppose I have I equals to, then I have to check I plus 1, then I have to check I plus 2 until it fills. So it will take a dash amount of value. Okay, this is the broad logic. Got it? In which I'm taking a for loop this, a for loop this, and a for loop this. It will not be n cube from this. If you are seeing it, will be really less. So what I can think of is a better approach in which I have just converted to the length. I have low and high. I have converted them into a string. Okay. Now I'm finding the length of this low and the high value and the low value. Okay, this is the result. So I have to check how many times do I have to iterate over. Okay, this dash value. Okay, so these are two values. So how can I find? 0 minus high minus low plus 1, in which 4 minus 3 1 and plus 1 2. So 0 to 1. Okay, I mean 2 is excluded in the pattern. Okay, so it will last for 0 to 2, in which 2 is excluded. Okay, now I'm finding a dash value. So dash value will be the low length plus the I. Okay, the empty dash that I have to fit. Okay, so now I will take the starting point, in which I have to take, take 1 or 2 or 3 and so on. Okay, so I'm taking 1 minus this value just basically means if I have 3 dash, so if I have 3 dash, okay, so the last value would be 9. Okay, so suppose I have 9 minus dash, it is 3 plus 1. 9 minus 3 is 6, 7. So 7 would be the last value that I have to take. Okay, so this is all the thing, and I have to plus 1 because in Python I have to use an exclusion value. So it would be 1 to 8, in which 8 is excluded. Okay, same here. Okay, now I'm taking a simple temp for the temperature for the temp, in which I have to take the sub string, and now I iterate over the starting index, and starting index will dash. And if the j is 10, then I have to break the temp and just do nothing. and we simply add the string. Okay, so in which I'm checking if it is low, if the temp value is lower than the low, then I'm not going to add this. If it is belongs to less than high, then I'm going to append this, and else I pick. Okay, this is a pretty good solution in which the thing is it is good. Okay, I belong to this category, so I can optimize this to a higher value. I can optimize this more, in which I am going to give a logic behind this. So let's delete this. Delete this. Now copy this. Now suppose I got the 3 values. Okay, now I have to make a 4. Suppose it is 8, it is 20,000. Okay, now I have to make the more value. So if I choose 1 2 3, if I have 1 2 3, then how can I make? I could make it 4. And so I just have to make add 4 value. I have to add 5 value. I have to add 6 value, 7, 8, 9, and I cannot do this 10, so I am going to break this. Okay, these are all the values that I can make. Okay, same goes here. If I have to make more value, so I can add 5, 6, 7, 8, 9, and 10, so it will be excluded. See this is the main concept. If I make a value, then I can just have to increase one value of this. Okay, so from the basic I can do is make a queue in which all the values will start from 1 to 10. Okay, 1 to 9 I will take. Okay, in which I'm going to keep on popping the value and just checking what I can just take. Okay, so in which I'm going to pop one value and check does it belongs to the low. Is it low? If it is not, then I'm going to increase the value. So I will increase by 2 and put this value into the queue. So it would be 12. Now same, if it is 2, then I'm going to pop this 2 plus 3 and I'm going to increase this in a value. Suppose I got in a 9, so 9 plus 1, 10, which is the wrong value, so I'm not going to add. This is the main concept behind this. So let's try to explain while coding. Okay, suppose I have a queue in which the value will be 1 2 3 4 5 6 7 8 9. Okay, this is a queue. And another thing is I have to check make a result value which I have to return. Okay, now in which I'm going to just checking, keep on doing a while loop, while queue, and just take the size of the queue. Now I iterate over the n, and I have to minus and keep on decreasing the value. Okay, so that value will not go for the infinite time. Then what I can think of is just pop the value. Okay, so let's take the value var equals to q dot pop. Okay, I'm just taking the first value. Okay, now I have to check if low is greater than equals to val and greater than equals to high. Okay, so for this is the main concept, this is logic. If it is true, it means if the val value belongs to the low and high, then I'm just going to append val. If it is not belongs to, suppose it is lower than, okay, so it will never go for high because the queue will just take it. Now thing is, if it is lower value, then take the least significant value of the val. So val mod 10, and the thing is, the val should never be a 9. If it is 9, then it will be 10. Okay, so if LSF equals to 9, then continue. Else what I have to do is q dot append val into 10 plus LSF plus 1, means last significant value plus 1. Okay, simple thing. This is only the value that I have to take, and it will be let's run this. An array, okay, we are getting size. Okay, the thing is, it will just continue, should not be here. I'll just take, if it is not 9, then if it is not 9, then I have to add this in a queue. It will just skipping and it is not getting the value of it, so it is correct. Let's make it in a one line. Let's try to submit this. So this belongs to 36 milliseconds. Yeah, it is much faster, it is less time taking. The time complexity is really less, but the space complexity getting increases by due to the queue value. But yeah, it is more precise and good approach, in which we are reusing the value that we have calculated. So yeah, that's basically it is work. So yeah, this is more the optimal way to solve this question. So yeah, that's all for this video, and if you have any questions, just comment it down and I'll check. Okay, have a nice day.